Hello friends, so today we are going to see how to sort different sizes of boxes, and each size of each box is going to go in its distinct direction. As you can see, when I click the play button here, start button, small boxes are going to be going to the right and big boxes are going to be going to the left. So when I do start here, you can see. So I'm going to give first some time, you see what is happening. So that is what we are going to try to develop step by step using our PLC with ladder logic programming. So we can first take some time and analyze and witness what is happening. Then after that you are going to dive directly into our ladder programming step by step, and also how to build this scene in our factory IO software. Don't forget, all the links of the softwares I use are in the description. Please don't forget to subscribe and also like, then also share to your dear friends. Don't be mean of the knowledge, please. As we continue, before we dive in the real PLC programming, once more, don't forget Reshamo Vocational Institute. It is located in Jinja. All these kind of skills, industrial automation, domestic smart wiring, can all be found at that institute. Please visit it and see what's there. The contact and the address is there on the screen. And also other kind of courses: hairdressing, tailoring, plumbing, automotive mechanics, welding, and any other kind of technical skill. Please find us at Reshamo Vocational Institute, Jinja. You'll never regret. So I think you have tried to witness all the big boxes are going to the left and all the smaller boxes are going to the right. So this procedure, we are going to see how to deal with it by PLC programming using our Mitsubishi PLCs. Let's go. So I'll first press here stop. There we go. Now what we are going to do first, we are going to open the very first software we are going to deal with. It's around, where is it? It is here, called Factory IO. So we are going to open our Factory IO software. Yeah, and there we go. Yes, that is it. After opening our Factory IO software, we are going to use already inbuilt scenes for easy construction. So I'm going to scroll down. And find sorting by height, basic, and you are going to click on that one. So that is our scene. It is already built, though we are going to modify it a bit. So there are some unnecessary things that we shall not need. As for now, I'm going to come here, view, remove the palette first, then actuator tags, also show sensor tags. That means I'm going to show the name of sensors and the actuators. Now what I'm going to first do here, I'm going to first delete some things. I'm going to delete this sensor here because we may not need it for now. I'm also going to delete this sensor set here. Press delete. And so now when we see here, we have the first line is going to sense the palette, the second line is going to sense low, the box which is of low height. This next line is going to sense a box of a bit higher height. So that is how we are going to be differentiating them. So when I give you a sample here of, this is what we call transfer left. When we click it, let me press here play. You see when you click, what happens? It brings to the left. Then we have here transfer right. When you click, it takes the other side. Then we have this one, we have the load. This loading, there are the rollers on it, as you can see them rotating to help it load. Then we have this one here is the conveyor left, then this one here is the conveyor right, then here is the entry conveyor. So what we are going to do, when I take it manually first, we analyze. I'm going to right click here. I'm going to give it at least after every 6 seconds to be emitting an object here. Then we are going to come here to base part to emit. We are going to say palletizing box, then large. I'm going to uncheck small and medium. I'm going to remain with the large and the palletizing box. So there we go. Now let me try to drive it manually. You see what's going to happen. When I click here start, I'm going to start conveyor entry. This is conveyor left, this is conveyor right. They are all on at once. So when I say conveyor entry, so when the box or load have not put load, this is unload. Load conveyor is here, load is here. So I'm going to remove unload. We are not going to use it. So we are going to start the entry conveyor. I know the box is coming. So when it is loaded, what load is not there? Load is here. When it is loaded, we stop the entry conveyor, then we transfer left. Are you seeing? Then we remove. Again we bring another one. The entry conveyor is bringing another box. It stops, then transfer left. Are you seeing? Then we stop that one. Again conveyor entry is bringing another one. You stop. Now let me assume this is a big box. I'm going to transfer it to the right. So now this one I'm doing it manually. Stop. Now I want us to do it automatically using the ladder logic programming. So at least you've understood the setup of the factory and all the inputs and the outputs we are going to use. But before that, allow me adjust. There are some sensors here. I'm going to adjust their position. This one I'm going to move it a bit on the third roller here. I'm going also to move it is a reflector around there. Then also this side we can close this one since we have finished the manual view of it. I'm going also to move this sensor here to the third roller a bit. And also move it is a reflector. Yeah, so we are going to change the positions of those sensors like that a bit there. So now that is a full setup of our factory. What we are going to do is now ladder logic programming. We are going to do the wiring straight away forward. I will go and open our GXWorks software for the PLC programming. Yeah, there we go. After opening, we are going to create a new project. we are going to leave everything the way it is and just say okay. Now I'm going to program the automatic part of it. I think the manual part of it I leave to you as a challenge. You will do in your free time. Here we are going only to program the automatic transfer part of it. Now we can first have the first rank. Here I'm going to have, this is F5 normally open contact. I'm going to call it X0. I press enter. Then another normally open contact, I'm going to call it X1. Press enter. Now X0 is the emergency, X1 is the stop. Remember they are normally open because in the real wiring in our factory IO we are going to use normally closed buttons. So here I'm going to have another normally open, it's going to act as X2. That one is going to be the start. So I'm going to have here our memory M0, and I'm going to have here a self launching. I'm going to have self launching of M0. So we shall compile and build. I love doing ladder programming when the PLC is in run mode, when it is in simulation mode. So I'm going to come here, debug, start and stop simulation. So it is already in run mode. I can minimize this. So I'm going to come here in what we call monitor write mode. You can edit the ladder logic as you monitor the process. So you are going to say okay. Now from there we are going to create our link between the ladder logic. The ladder logic is not yet on that I want us to be editing when it is online. So we are going to minimize this one and we open our link, that is MX OPC Configurator, to help us connect our ladder logic to the factory IO software. Now me, I have this one, I'm going to delete it. For you, you may not have any. So I'm going to right click, say new MX device. You are going to go to configuration. We say GX simulator 2, not simulator, GX simulator 2, as you see. Then you say next, finish. You say okay, you say save. Then it's going to say right click to add a data tag. I'm going to say new data tag. Now here is where we are going to add all the inputs and the outputs that we are going to use in our programming. So I'm going to have here X0. I mean this one is emergence, and that is X0. So X is for inputs. X0 I'm going to say save new. I'm going to have stop. It is X1 already there, save new. I'm going to have start. X2 is already there, save new. Now I'm going also to start addressing the sensors we are going to use. So this sensor, the downer sensor for this one, low sensor, I'm going to call it X3. So I'm going to have here X3. I'm going to call it small. That is a sensor for small box. Save new. Then X4 of course is going to be the next line for large, and that will be helping me to detect the large box. It will be X4. Save new. Then also I have this capacitive sensor, this green here. This capacitive sensor around here is going to help me detect whether the object is already loaded on the screw conveyor, and I'm going to call that one X5, and I'm going to call it loaded. That means the object is already loaded. Then I have save new. Then now I have this on the right sensor here. This one is going to help me know that the object has already been transferred to the right. So I'm going to call that one write sensor, can call it write sensor, object transfer to the right, then save new. Of course, the remaining, the other side, I'm going now to call it left sensor. Save new. So those are the input devices that we are going to use. I think they are all done. Then here, now I'm going to start from Y0, and those are the output devices we are going to use. Y0, I'm going to start, that is entry conveyor. Now let's see, let's start with the lamps. Y0 is the stop lamp. Say save new. After save new, next is the start lamp. Start lamp, save new. So now Y2 is going to be the entry conveyor. Save new. Y3 is going to be, and give it left conveyor. Save new. Then Y4 is going to be right conveyor. Save new. After save new, then Y5 is going to be the load conveyor. Those are the rollers on the screw conveyor. The rollers on the screw conveyor. Then save new. Y6 is going to be the right shift. Right shift, that means taking the object to the right. Save new. Then Y7 is going to be the left shift. All those ones are output devices, please. Then I'm going to say save. You see, all these are the inputs and the outputs. The X are inputs, the Y's are the outputs that we are going to use. I can put here in monitor mode. So here it must give us all the qualities good. Okay, so I'm going to minimize this. Now we are going to go straight away forward to the ladder programming. What we are going to do first, let us register all the outputs. Now the stop lamp, here I'm going to give normally closed of the memory to power Y0. Come here, the coil, give it Y0. Then we are going to have the normally open of the M0 still, and we are going to power Y1, that is the start lamp. Enter. Then we are going to have normally open still. I'm just doing it the basic way, the simplest way. Then we are going to have Y2. Then again normally open of M0, we give Y3. Then again the normally open of M0, we give it Y4. Yeah, we are just addressing all the outputs before we start controlling them, how they are supposed to be coming on and off. Then again I'm going to have here M0 coil. I've stopped at Y4, that's Y5. Then I'm going to have again M0, then the coil of Y6. Then again I'm going to have M0 normally open, feeding the coil of Y7. I think all those are all the outputs that we have. Now what next is designing the logic on how to switch on and off each output according to how we want. Now here the next logic, I'm going to have here a normally open of M0. Then I'm going to have these two sensors, this sensor at the right and this sensor at the left, that is, I'm going to have normally open of X7 and normally open of X6. Those are the sensors. They are going to be powering some coils. Here is going to power for me a memory called M1. Now this is the logic how I want to be identifying the sizes. Now here these are normally open, but now these sensors this way are normally closed contacts. These ones are normally closed. So when I complete, when I power on, when I put in simulation, they are going to close. Actually, the logic behind, sometimes I cannot explain it very well, but try to think. So from here, now I'm going to have my two sensors, that is the low sensor and the high sensor. I'm going to have here normally open of X3, that is the low sensor. I'm going to have normally closed of X4, that is the high sensor. Height is going to power M1. Then I'm going to have here a self launching of M1. Are we there? So from there I'm going to add here a vertical line. It is here SF9. Say okay, I mean a horizontal line. Then I'm going to have the very sensor. This means if X3, that is normally open, this is X3, okay, another normally open, X4, okay, they are going to power for me the coil of M2, okay. Then I'm going to have a horizontal, a vertical line here still. Then I'm going to have a launching here of M2, that is the memory. Then I'm going to have here a vertical line. Then I'm going to close this one with a horizontal line and say okay, or Control Z. So here when I click horizontal line, it is stop at the connection. Check this, say okay, it is going to stop there. So now this logic here, this one is the right sensor, this is the left sensor. Those ones are going to stop. Now M1, it is going to be a sense for the smaller box. M2 is going to be a sense for the big box. A smaller box, when only X3, that is the first line down, is cut, the laser line of the sensor is cut only, and this one X4 is not triggered, is going to switch on M1 and is going to self hold. So by the time it reaches the load screw, to know that M1 is the one which is self holding. When it triggers both, when it affects both X3 and X4, that is the line below and the line up, that will be a large box, is going to switch on M2. But remember, M1 and M2 cannot be switched on simultaneously. So when the object has already been transferred to the left or to the right, these sensors are going to open and they cut off this sensing of the size of the box, so that the box which comes afresh again is going to be sensed afresh. It is hard for me to explain, but bear with this session. Let's go. Now after that one, so when we come here to factory IO, remember this is a load capacitive sensor that detects. Once the object reaches here and is detected, it is going now to trigger the screw to transfer either left or to transfer either right, according to M1 or M2, the one which will be on. So now that those outputs are Y6 and Y7. So when it reaches, they are going to be powered with the sensor, that is X5, the capacitive sensor. Also this one is going to be powered by X5. So now this one is going to be powered by X5 when M1 is the one sensed, that is small, and this one is going to be powered by M2, that is when the large box has been sensed. Are we there? Then I'm going to put some control, that is self-holding. I'm going to right click, edit, insert row. Also here right click, edit, insert row. Then I'm going to come here and put a self-launching of Y7. Also click here and put here a self-launching of Y6. So that is the logic. There we go, but it's not yet complete. The input conveyor, that entry conveyor that brings objects. When the object is at the loading screw, at least these other objects should stop and wait for the other one to be transferred to the right or left before again others come. So here I'm going to have here a normally open of M0. Is it M0? I'm going to start by normally open of X5. I'm going to say X5. Then I'm going to put M0, that is the very first memory. Then it is going, this conveyor can be powered. I'm going to put here self-launching of, this is normally closed, I think, normally closed of X6. I'm going to have here normally closed of X7. Then I'm going to have here normally open of M3, that is self-launching. Here we are going to put vertical lines. Also here join with the vertical line. Also here join with the vertical line. And also here join with the vertical line. So all this setup is going to power M3, memory 3. So memory 3 is going to control our input conveyor. There is an error here. X7 has to be closed, so click at X7, come to normally closed X contact, again type X7. Okay, it's going to come to normally closed. So X5 is also supposed to be normally closed. Yeah, type X5 is going to come to normally closed. So now this logic of M3 is going to affect the entry conveyor, which is Y2. So I'm going to have here a normally open of M3 Y2. So after that, first say compile, build, just say yes. Say okay. Now it is already, you can first go through the program slowly. I'm going to move this one up. So that is how we have managed to come up with the ladder logic. So when you move slowly, it is just as simple as you see. Though it is not the only way of doing it, you can do it in any other logical way according to how you understand circuitry. But for me, this is how simply I've managed to do it. So I'm going to come here online, write to PLC, come here and select all. Here it is select all, then you say execute, and you say yes. Say yes to all. Okay, wait for it to complete, then you say yes, say okay, then you say close. So it is done. Now not yet done, but let's give a simulation and see. Now we are going to minimize this one. It is already in simulation mode. Remember, we are going to open our factory IO. Then we are going to come to file, we say drivers. Then we are going to come here and say OPC client DAUA. We wait for it to search. Even though it says server not defined, it is okay. You can come here to configuration. You come to browse servers. You wait for it to browse this checkbox here. When it is done, you right click. It is going to bring only Mitsubishi. It has brought Omron also because I have two servers there. So select Mitsubishi. It is the one for GX Works that we are using. Then click here to browse nodes. Then go back. So you are going to see our PLC has come here. Now what we are going to do is going to start the wiring. We have here the stop push button. We are going to put it at stop. Then we have start push button. We are going to put it here at start. Then we have pallet sensor. We have not used it. Low sensor, I called it the small for detecting the small box. Then loaded, that is the sensor that shows that our object has been loaded on the screw. Then high sensor is the sensor for detecting large box. I called it large here. Then I have emergency stop. I put it around here. I think those are the only inputs that I used. We have at right entry, that is the right sensor. Why is it? I called it right shift. Yeah. Then we have at left entry, that is the left sensor. I called it left shift. For you, if you have forgotten where we have got all this, it is here in our configurator, this one, where we set all those variables, the inputs and the outputs, here in the MX configurator. So we are going to come to entry conveyor. We are going to put it here at entry conveyor. We have conveyor left. We are going to put it at left conveyor. We have conveyor right. We are going to put it at right conveyor here. Counter we have not used. Load, we are going to put it at load. Do we have it even? Yeah, it is the load conveyor. Then reset, we have not used it. Start light, we are going to put it at the start lamp. Then stop light, we are going to put it at the stop lamp. If you have been following and doing everything step by step, you will be having all this the way I have. Then transfer right, I'm going to put it at right shift. Then transfer left, I'm going to put it at left shift. So I think I've already finished, yeah, configuring all what I had. So I'm going to click this one back, and we try to give a test and we see if we are on the track. So I'm going to minimize this one to give a clear view. So I'm going to click play here, simulation. Then I'm going to come right here and say start. If I say start, you see the start lamp is lighting there. So we see what happens. That is a smaller box. Oh, sorry, there is some error. Yeah, there is a smaller mistake. Now, why the thing is not moving after reaching the screw conveyor? We are first going to say stop. Let's first stop our system. We stop simulation. Then let's come to drivers. Let's check. Transfer left. It is transfer left with at left the sensors. They are the same line, which is wrong. So at left entry, this is a sensor, is supposed to be at left sensor. Where is the left sensor? Which is here. Move it from here up to here. Then at right entry is supposed to be at right sensor. Have you seen the changes? Instead of putting it here at right shift, at right entry, put it at right sensor. This is the sensor at the right entry. So those few changes, we go back and check. So we are going to play back our simulation. Then we press start and we check and see. Once again, don't forget Reshama Vocational Institute in Jinja. Go there for your skills. You see a smaller box is going to the right. Reshama Vocational Institute Jinja for all your automation skills, domestic wiring, electronics, automotive mechanics, and any other technical skill. Please find the location and the contact on the screen. I think our project is wow. You see, big boxes to the left, smaller boxes to the right. Take time and analyze what you have done. Please, what you have not understood, post your comment in the comment section below so that we can correct where necessary. Please don't forget to subscribe, like, and also share. Please share and help to increase the audience. So that is it. See you when you see me in the next tutorial. That one has been object sorting by size. Can give you some time to go through what is happening. See you when you see me. Don't forget the softwares we have used: GXWorks, link in the description; MX OPC Configurator, link in the description; Factory.io, link in the description. So next time we shall be seeing how to deal with programming this panel here in HMI, digital touchpad. So I can press emergency and the system will stop and I will say goodbye.